Hi, everybody. Hi, thank you. Yeah, I'm a real person. It's nice to say thank you very much. Appreciate it. Hi, everybody. I mean, it's only 4. It's not that late, and we're all staying for the party, so, let's just go with it. Okay, so I'm going to go ahead and begin, even though we've got 30 seconds before I have to, so you guys get bonus content. This will be excellent. I met a handful of people over here, just out of curiosity, quick show of hands. I'm not going to ask you any follow-up questions. Do you feel like you're an architect, or are you an architect? Either one. Yes? Oh, okay. That's a fascinating number of no's. All right, that's cool. Well, this is, for both of you, obviously, this is an exciting title, for all of you forgetful architects and all the new engineers out there. The number is that about 50% of all developers at any given time have less than 5 years of experience. So the reality is there's always new engineers coming on board, and I think we can all agree that the barrier of entry into this field is a little bit higher than like a sweeper, right? There's a lot going on here, and it can be overwhelming sometimes to think about all the different things you have to learn. I'm also a computer science professor at university back at where I come from, and students are incredibly intimidated. When you just Google software and just imagine all the things that come up from that, and all the things they think they must know in order to get there. And they don't have the advantage that a lot of you old guys do, where they got to see the HTTP spec start at 1 and work its way up, right? Instead, they're starting now with all the complexities around CSS and all the other things as well. My heart goes out to them because it's a difficult place to go into for sure. And even with ChatGPT, honestly, I think we all know that ChatGPT makes our lives a little bit better, right? None of us who use it believe the hype around it's going to replace our jobs, that's for sure, unless you're a very crappy developer. And that being said, it also helps new students, but it doesn't help new students too, because they get to sidestep some of the things that you got to screw up, and you'll never forget screwing them up, right? That's the thing. And so it's really hard. So welcome if you're a new engineer for sure. All right. My name is Jerry Nixon, Jerry. Jerry. I live in Colorado in the United States, and I've lived there for a long, long time. I work at Microsoft. I'm on the SQL Server team. And the primary product that I work on is SQL Server, because I'm on the SQL Server team. And but one of the teams I work with that is serious is the Data API Builder team, and we'll talk more about that in this, but it is a big deal. Out of curiosity, how many people use a database? Great. All right. So I assume you all use SQL. All right. So I'm kidding. I know you don't all use SQL, but it's kind of fun. All right. So a little bit about me that's worth saying, and then I'll get on with it. This is me on the Enterprise. This is me on the bridge. This is New York City. They had a fully restored portable bridge, which was incredible. And I did get the picture with this lady in it, which is ridiculous because she's not in uniform. But nonetheless, it was real, and it was awesome. Does anybody know which Enterprise this is? I'll give you a hint. It's NCC 1701- and then the letter. It is D. It's always right when I go to Germany. They get it right every time. And it's just, you would think with a room of nerds like this, if I asked you what color Darth Vader's lightsaber is, you would have no problem. But yeah, we can't do that. All right, let's move on. So that's me. By the way, I've worked at Microsoft for a long, long time. And I was a developer evangelist for about a decade. And so I used to talk about XAML and all kinds of cool things that have kind of seen their day. And then I was a field engineer for the longest time. And this is where it really matters. I was a field engineer working with what Microsoft calls its F15, right? The top 15 customers. So just imagine the 15 largest customers in the world. So those are the ones. Super annoying to work with. But really, really big, doing cool things sometimes, but sometimes not. And the reason I bring that up is it drives me crazy when I hear people say that's a best practice. Oh, yeah, well, that's a best practice. Usually they just say that as some sort of cover for something they're saying because they can't think of a good argument for why they're right. And so it's just a best practice. And it drives me nuts because there is no such thing as a best practice. I suppose an example of a true best practice would be not to use SQL injection. I suppose that would be a kind of best practice. But a true best practice usually comes from the cover of magazines, and it just drives me crazy because the sorts of things that people say are best practices really are just good for them, or they happen to have seen it work, or in a specific environment it happened to actually work. But what they don't account for are the weird politics of my company, or you don't understand the budget constraints, or the fact that my entire development team is very junior, or the fact that we were just merged into another company and the technology set is just not at I don't have the option to make a change, right? All of these things. And so you're like, oh, okay, so the opposite of a best practice is a worst practice. So everything else is just a practice or a worse practice, and it's not true. There are so many ways to do the same thing and to get it done. And let me give you this one little tidbit that you may not know any other way. When you look at companies like Twitter, for example, and you look at the things that they do, and their architect goes on to some podcast and starts talking about a solution that they did. I didn't mean to do that, architect. I'm sure whoever it is a real architect. But just to remember that companies that size can afford incredible mistakes. And they could just pay their way out of it. It's unbelievable. And so when they're like, oh yeah, we decided to do all this craziness over here, and so far it's working, and that you're like, that's a best practice. But it's not a best practice. It's because a company that size they don't have to think so strategically. They don't have to think at this point of like, I have about 3 weeks to get this built. After that, I will be busy with other projects, and I have to get this so that it actually works and actually runs and can be maintained. They don't need to think in the same way, and so they can just throw money at problems and solutions in the way that you can't. And that's where a true architect sort of comes into play here. For example, if you think about a best practice and how it's changed over time, in the 90s, we had spaghetti code, which back then was pretty good. Like it's funny because now, in retrospect, we're kind of chuckling at it. But, I mean, sure, we had go-tos and we know not to use them now, but it was actually functional. And by the way, the economy still seemed to manage. It's funny. Even with terrible spaghetti code, we still had applications that worked. And then we upgrade to multi-tier, right, where we have layers like a lasagna. And so in the 2000s, everybody had their 3-tier solution, and it was exciting, right? Multi-tier, and you could go all these layers, and we're, oh yeah, it's so not spaghetti anymore. And that's true. And then about 15 years ago now, in the 10s, I guess, is that what you call it, the 2010s, I guess? Then we have microservices. Microservices, which starts a brand new religion, by the way. And so now all of us are like, oh, microservices, you're doing them wrong, by the way. I mean, that's just that should be the subtext of every time you see microservice. And it was like little ravioli, little bitty, little compartmentalized things that you could deliver. They had their own database sometimes and all these other mechanisms. But what's funny all the way around is each of those works even still today. It turns out that if you have a 3-tier application and not microservices, it still runs today, even still. In fact, many companies still have their legacy applications that somehow still make them money and employ people and pay people's mortgages and all the other things as well. So it's just one of these things where you see these kind of eye roll moments where like, oh, I'm gonna write this in VB. Or, yeah, sure. Let's just say VB. I'm gonna write this in VB. You're like, eye roll. Like, well, you do not know my situation. Like I have to do it in VB because we've got 18 other line of business applications, each one written in VB. And so we've only hired VB developers, and we're only training VB developers. Well, you should be upgrading. You're like, you do not pay the bills. Like, it's just one of these crazy situations where it's almost like architecture shaming in a sense, where you look at the results of others and you're just like, it's all wrong. But yet, it's because of the situation that they're in. Often, some of the hardest decisions we make are the compromises based on the realities around us, no doubt. All right, so best practice, let's put that aside. Let's think about the word architecture. If you're an architect, what is your job? Like, does anybody have an interesting definition of the word architect versus developer? Anybody? It's fun. Okay, so none of us know what an architect is, so you're all at the right session. We're going to talk about architecture, and architects are the ones who build architecture. No, architects are the ones who are responsible for the most expensive choice. That's what it is. They are the ones who are responsible for the thing that is the most expensive to change later, and it must be made in advance. Now, every moment that the project continues is the current moment, and so we will have to make a decision now for the rest of the project, and that will be the most expensive choice for the rest of the project. And so you maintain this role of architect all throughout the project. Anybody who can whiteboard an entire solution, soup to nuts, at the beginning of a project, you're just building a notepad. Like in a real world project, there's too many unknowns and too many mysteries that will come up. And it's not about being agile, it's just about being realistic, that there are things that must be added and must be removed. Now, I would add to this architecture discussion of saying an architect's primary role is to figure out what things in the solution must be left out, more than what needs to be brought in. Like you might think, what are all the boxes that need to go on the whiteboard? But more importantly, I think that you are a guardian of what keeps out of the solution. Because the more you add in, the more complex your solution will naturally get. There's nothing wrong with complexity, although we prefer simplicity. We certainly don't mind sophistication, which is a much nicer word than complexity. But at the same time, we want to minimize everything as all the way through. Because the less you have, the less there is to break. That's always going to be the case. However, in the real world, we have to add all these components one way or another. So let's think about what the components might be. What are the choices you as an architect get to make and are paid to make and are also often held accountable for? That's kind of the reality of it. Maybe that's a better definition of the architect, the one who's blamed. Okay, but here's an example. The software control, the source code management tool that you're going to use has to be decided. So let's go greenfield, pure greenfield, right? Which CI/CD plan you'll go through, what type of management of your project you'll have, the IDE that you'll have, but that's not all, which cloud you'll use, because there's plenty of options. You'll have to, this is a long-term dating commitment you're about to make, whether or not you'll use containers and how you'll host and orchestrate those, the serverless technology that you'll use behind the scenes, the languages that you'll use, because not every language is available in every situation, so you'll have to decide what that is. Or you'll also have to pick a language based on the longevity of the language, but also being able to hire developers who are willing to learn or code in that language. It's very important. So sometimes you'll actually choose a language that seems crazy, but you know that it'll be easier to hire a developer later. Which front end you might use, because there's so many choices, and you have to think through which one has longevity and shelf life beyond just the next handful of years, or whether or not the maintainer of that repo will retire someday soon. Which back end that you'll end up using, because each one is different for a different reason. Some are faster and slower than others, easier to maintain, harder to host. Then you get to decide whether or not you'll have AI and which model you're going to use, where the model will be hosted, how you'll pay for that model, who's going to train that model, what you train it on, what the pipeline's going to be, what the different communications of your team, that seems stupid, doesn't it? But it's so true. How you're going to interact with a database, there's so many options there as well. Then, it's not done, yeah. Then you have to think about the UI itself and the layout and how you're going to put all these things together. And even if you think to yourself that these aren't the things that an architect really does, these are the things that an architect is looked for or looked to for, right? You're like, what should we do? What should we do? And you as a good architect, of course, build a consensus with your team so that they feel like they're making the decision. But these are still on your plate, like it or not. You get to think about how you're going to deliver it, how you're going to package it, whether or not you're going to sell it, how you're going to handle upgrades, what do hot fixes even mean. Then you get to operational things, like it's crazy. Telemetry and the performance of it, whether or not it's accessible, whether on and on it goes, right? It's so difficult when you think about just approaching, well, we're not done yet, right? So when you think about approaching software, it is just an overwhelming tsunami of choices and options that you get to make. Whether or not it's going to run on every operating system or just one, and if just one, then which one? And of which version it's going to be as well. Whether or not it's going to be mobile and which framework you use once you choose it's mobile. If it's iOS or it's both, does that mean it's also on an iPad as well? It's brutal. It's brutal. All right. Whether or not it's web, but who cares about web? That's good. But whether or not you have a database. Which database you're going to use. Obviously, we'll use SQL Server, but what will be the one we make fun of during class and stuff? So that's going to have to be decided as well. Whether or not you'll have a NoSQL database because JSON matters. Are you going to break it all apart and make it relational, or are you going to leave it as a single document? Whether or not you have a graph database, or how you're going to handle search. Whether or not time series matters, and on it goes. Hopefully this feels exhausting. We're not going to cover any of these things, by the way. I just want you to know that these are all the realities, right? When we sit and think, and we were brainstorming, we would come up with a list 5 times longer than this if you were helping me. It is crazy all of the things we get to think. We haven't even gotten to security, right? Because that always comes last. But the thing is, there's so many things to think in our mind. And it's brutal. But here's what we're going to be talking about today. You need to understand every component in a solution, of course. That is true. Your job is going to be saying no. That is you. You, the architect, get used to saying no. We're not doing that. But what you really secretly mean is we might do it, but just a little bit later. Not now, right? That's what you're really saying. Like, what if we just got a couple of things working? Now, I realize some foundations must be built. Certain things have to be put in place earlier than you actually need them. But generally, that's not true. And if you can be the champion for simplicity, then you truly have the soul of an architect. That's all there is to it. If I don't have any tattoos, like the world does, but if I did, mine right here would say, simplicity is the best architecture. That's what it would say. My wife would love that. And it is just one of those things where that's what we care about. All right, this is the meat of today. So we're going to go look at this architecture. You're like, oh, that's nice. All right, so I'm going to walk through this, but I'm going to walk through it in a way that I guarantee at the end of this talk, you'll have a comfort for every box up there, and you'll be able to make an argument for every one of them to still be there. But I am not going to recommend that they all go there. Instead, I'm going to recommend that you instead understand which one should not be there. Because you as an architect are the one who says no. You are the one who takes everybody's dream. Oh, I heard about this new framework, and no, we're not doing that, right? It doesn't mean no. It means not right now. We might do it. Let me dabble on the weekend and see for myself because I never heard of it till you mentioned it. But we might come back to it, right? But it's okay to say no. Because in the end, that's the role of a really, really, truly good architect. All right, so every project starts with the client. That's where we're going to begin as well. Does this architecture look somewhat busy and overwhelming? I hope your heart says yes, because it does. I don't think it's going to in the end. Okay, so if you build an application, we'll call that the client. Every client's going to need a database. If you're not talking to a database, then it's not a data-driven application. All applications are data-driven except Notepad and I guess maybe like Solitaire and stuff. But very few applications don't have a back-end database of some kind. My goal is that you would separate them and not have them inside the same executable, but that's okay if you do, because I don't know your business situation. So you have the database separated. Of course, we're using SQL Server. All right. Now, the next thing you say is talking directly to the database feels wrong, and you would be right. The reason that talking to the database feels wrong is because you have to leak the schema back to your application, and now you have coupled the schema and the application together. You've also made it so your app developers have to be good SQL developers, and that doesn't always happen. It also means that you tend to see SQL mixed in with like JavaScript, and it just feels wrong. Just feels wrong. And so instead, we introduce the API, and the API, Application Programming Interface. Yes, there's so many acronyms in the next few minutes. Okay, so we have an API, and the reason we have the API is to abstract everything away, separate the concerns so that the developers who write the API don't have to be the ones who write the app. This is really a good decision to make, right? It doesn't have to be thick, it doesn't have to be like fancy, it just has to be an API. However, you haven't solved a key problem, and that is to be able to talk to any database, you need a database driver. That's just the way that it works. Database drivers are nothing but trouble. Database drivers have to be installed. Database drivers go through versioning, and often that versioning is because of security concerns. And so you must make it so that your client, which is coupled with your API, which is coupled with your database driver, must be ready to be upgraded regularly. If not, if for no other reason, it's for the database driver. And you think to yourself, the database driver we use today works. Why would I need to upgrade it? And it's just because there are many under-the-hood reasons to do it. I'm on the SQL team. My team is also the driver team. I can tell you that people who do not upgrade their driver are not doing themselves a favor. Not only do drivers get faster over time, they get incredibly more secure. Because of things that we never accounted for before that made it so that it was insecure, now we fix those as well, when they just keep on rolling, right? And so not to do it is a brutal thing. However, what if we moved the API next to the database instead and took it out of the client? Now we've solved the problem of database drivers. Database drivers are no longer in the client. It also makes it so that the API is completely removed from the app that you are building, which makes it so that you can not only use different types of developers to do it, but you can also now deliver in different cadences as long as you maintain the same contract between them so that the surface area stays the same. That's the easy part. The hard part is actually developing and implementing it in a good way. Terrific. Now, we have an important under-the-hood piece here, and that is to make sure that we have full telemetry. So this is usually the things added last. I mean, I jokingly said that security is added last, but usually telemetry is added last. But we really need to think about it up front, because telemetry allows us, especially in a separated environment like this, to be able to have all of your logs and then to correlate them together so that you can see and debug all the operations that are going on in your application. This is not going to help you at all during development. It's only going to help you after you've pushed this out and you're trying to debug a problem while your boss is breathing down your neck. That's just the way that it goes. And yet, we still put it off. But it is a very important part. If you don't use open telemetry, which is what everybody uses today across all the technologies, which certainly is the most beautiful way to do it, but there's so many other ways you could do it. Right? What are the other ways? There's just so many. Open telemetry is what everybody's using. I recommend you look into it. All right, so let's think about this. What if the database was no longer tied to the API, and the API was not tied to the client, but instead we separate those so that we can also separate the API itself, making it so the write operations and the read operations are in different places. So they could be physically different places or logically different places. But the whole idea is that the operations that are intended for write can be isolated, and the operations intended for read can be isolated. This doesn't have to be a change to your code base. I could just install it twice, and I can make it so that all my write operations point to the top and all my read operations point to the bottom. This is like the CQRS pattern. It allows you to separate all of this work, because it turns out that your application is extremely heavy in writing. It must write constantly, and it must write fast, and it must be good. But it doesn't read very often, right? So just a little bit of read and a lot of write. Now all of a sudden it allows you to scale your write operations in any way you want, and allows you to unscale or like decrease the size of or maintain the size of your read operations in a totally different container or server or however you've deployed it. Right? This is a beautiful and easy first step to make your application faster and a little bit better, truly. And without having to do very much on the technical side, for sure. However, the API is not the only thing we would do in this situation. We can also make it so that the database itself gets split. This is not a special feature of SQL Server. This is a feature of every server out there. There are no databases that can't actually replicate to another database and give you a read-only replica. That read-only replica is on a separate machine, using separate compute, using separate file I/O, which makes it so that when you're writing as fast as you can to your write database, then it automatically, usually through its logs, so there's no performance impact, comes down to its read replica. You can read and make it, you can crunch the numbers, whatever you want, and never impact the speed of your writes. That's really nice. You can also have multiple reads if you want to as well, but we're not talking about that here. So now, the client now talks to the write operation, the write API. The write API talks to the write database. The write database automatically synchronizes down to the read database. The read database then gets pulled from the read API into the client. Everything is isolated, and you've barely done anything. Right? Honestly, you've barely done anything. This is a change in your connection string and deployed in two different places. That's all. This is nice. This is cheap architecture. This is low-tech architecture. This is simpler architecture. And we're just getting started. Okay. That being said, there is a tier. I don't know if all of you know this. There is a tier in Azure that you can pay for. Only our top customers can get it, where the speed of light can actually be increased. I'm kidding. There is no way to increase the speed of light, so that the transfer of data from one place to another always is the same. No matter how clever of an architect you are, it'll always be the same, which means we get this term that Google made up for us called eventual consistency. Eventual consistency says that two things will eventually be in sync. The goal for us is to make it milliseconds, so fast, in fact, that you think it is actually always in sync. I don't know if earlier it was the quantum computing talk, and they were talking about how you can have two states connected, and you change one, you change the other, and you feel like they're exact simultaneity. But that doesn't exist in the real world. It does in the quantum world, just not for us. And so instead, we have as fast as you possibly can. That's about as good as it gets. Each database, including SQL Server, does this extremely well. Right? Their whole goal is to make it so that we can synchronize with the read replicas as fast as possible. But we need to understand that only so much data can pass through so fast. Even with the most expensive thumb drive, when you put it in and you transfer that movie over, you still get to wait, right? It's just the way that it works, because there's just a technical reality that all of us are bound to. So even when you create something like this, it's good for us as the architect to understand the caveat we've introduced into our solution. It is so much faster to read now, and it doesn't impact the write, and look how low-tech all that was. Just know this. There is going to be a slight delay, which means if you do a simultaneous call to read and write, it will not return the same value, right? Your write value will not be there. You must make it so that they go in series, and then you have to measure what it means to be eventually consistent. But it's worth it, because it's such a cheap and easy way to make your application better. Also cheap and easy is to introduce some other services and not make it so you have one enormous service. So if you have microservices or you have macro services, or let's just call them services, if you have services, then good for you. That's the way it should be. Because it feels to me like I want to be able to hand off not just to my team, but I want to be able to think in my mind in tiny little cordons so I can say I'm only doing this work and I'm only doing that work, and I don't have to think about how everything ties together because I've separated them nicely into separate projects or perhaps separate solutions. And so here the client now talks to 3 instead of, well, 4 if you count the read-write separately. Talks to 3 services instead of 1. All right, that's good. That's what you want, right? Breaking it apart a little bit like this. However, you've introduced a new problem that you're going to have to solve. That's because everything you introduce is something that you're going to have to solve. So in this case, you're going to need to figure out how all of these back-end systems are going to talk to each other. So in this case, they're all your systems, so it makes it really easy. You'll introduce the concept of a service bus, perhaps not the tool called service bus. Azure has a tool called the Azure Service Bus. It certainly does this, but there are many, many solutions out there that are open source. You could just add it as a library, and now you have that capability. So don't feel like that it has to be a specific product. It's a concept. The concept of a service bus is a little bit like a postman, right? He takes a message, and he gives it to the right person, and he makes it available, and he puts timers on it and all the other things that you might have. Return to sender and all the things like that. The service bus allows all of these to feel as if they're connected even though they're separated, and so you don't lose the ability to have this interconnected flow even though you've separated everything so development is easier. And when you think about upgrading your application or going to the next version of .NET or whatever, you can be like only the top microservice, only the bottom microservice, and you can move in these small little seams that make it so things are actually manageable. And that's because you as the architect did a great job of keeping things simple. Right? That's nice. All right, so with the service bus, you'll have this idea of a dead letter. So this is the not the green path, I guess is a better way to say it, right? The happy path that goes this way is always going to be countered by the bad path. And so the bad path is the dead letter. So you send a message into the service bus, you're actually trying to talk to that third service or whatever from the first, and the message is lost. It falls into the dead letter box. Here's the thing with the dead letter box. It works. It totally works. But nobody will handle the dead letter box if it's not for you, which means if I introduce the concept of a service bus, I must also introduce the concept of managing the dead letter box. Because what if it fails, right? What if it fails? Okay, let's not spend too much on that. Just know that it's there and it's a thing in your mind. Assuming that your company is bigger than one application, the service bus is the lever that allows you to talk to all the other applications out there. So because I have my new application on the left, I also have system A, B, C, and D that have already existed in my company, and I need to interact with them one way or another. Now, if all I'm doing is merging the data together for reports, I don't do this. But if I need to operationally engage with them, making it so that they do something as a result of something I just did, then I want to make sure that they're connected to the same service bus I have, which means the service bus is not part of your solution. The service bus is part of its own solution that is shared by multiple services, which means you have created yet another beautiful scene, making it so that all of your upgrade options and all of your levels of effort can be isolated to different parts of your application. Okay, congratulations, by the way. This integration probably will take a year because it's hard because the guy who owns System C is a real jerk, and so he's really difficult to interact with. But you have it nonetheless. Now let's go back to the client for a second, which is no longer talking directly to the API. We've introduced in between the API and your client the APIM, the API manager. If you have any APIs in your application and you don't have an API manager, I'm going to be the one to say, I think you're doing it wrong. I think that you should have some sort of app gateway or API manager in between you and the API that you're calling. It's a little bit like telemetry. It is not going to help you at the beginning. In fact, it's only going to add to the work that you have to do at the beginning to add an API manager or some sort of app gateway. That's because when the day comes and you need to upgrade your API, you will go from version 1 to 2, and you will immediately love yourself for introducing an APIM. because it will handle the transition from from version 1 to 2, and then version 1 to 2.1, and then 1 to 2.1.1, and rolling them out, and A/B testing, and all the other things that you need to do. In fact, an APIM can take the payload that you're sending to your API, transform it in the APIM as the next version for you, and then pretend to be calling so you think you're calling version 1, you're actually calling version 2, and the APIM is making your payload compatible for the second version. It also handles denial of service. It also handles load balancing and all the other things that you should have to simplify the overall use of your API, including making it so that your 3 microservices feel as if they're a single API surface that you're calling. That's really nice. All of these things matter. And it's not a product. You can go get an open source tool and add it to your library today, and you can have an APIM experience, right? But not having not having that, you need to just look yourself in the mirror and ask yourself why, because it is so valuable. And so I told you I'm a computer science teacher. So I tell my students, I'm like, listen, you're not really writing code for the computer so much as you're writing code for the maintenance developer that comes after you, right? It's the next developer that really matters. And if there's anything you need to remember or think of, you should think that the next developer is a killer. He's an axe murderer. And you don't want to make him mad. Instead, you want to keep him happy, right? And so he receives your code, he opens up the box, and he's like, what the crap? Are you kidding me? And it's like knock, knock, knock in the middle of the night at your house. So you don't want that to happen. Instead, you have to think the maintenance developer, you want, for their sake, I'm going to do everything really, really well. Really, really nice, right? And so one of the reasons we introduce beautiful tools like APIM is because when the day comes and you're off of this project and the next guy now has to version your API, he's like, we only had an APIM. Now I've got a da-da-da-da, right? And you're like, that's just how you get killed. All right. It's a dangerous job to be an architect, that's for sure. APIM, API Manager, App Gateway. Is there another name? Usually there's one other name I can't think of. Out of curiosity, no, I don't want to do that, because now that I've said if you're not using it, you're the dumbest person in the room. Raise your hand if you're not. No, I'm just joking. All right, let's move up now to what we can do to our microservices individually to add capability to make them better, right? So these are concepts, not actual tools, but nonetheless, it works fine. The first is cache. There's 2 types of cache. There's level 1 and level 2 cache. Level 1 cache, in fact, Jody gave a session yesterday. Some of you may have gone to that session. He's the maintainer of Fusion Cache, which is an incredible library, very easy to use. Level 1 cache allows for a request from an API to be put into memory so that the second request for the exact same data just gets pulled from memory. There is nothing faster than memory. In fact, there is nothing, a database is incredibly fast, but it's also incredibly slow. Here's a tip. If you want to make your SQL server or any database faster, there is one thing that'll work for all databases of any brand, that's for sure. And that is query it less. That's all there is to it. If you just query it less, it'll behave better. And so, for example, when my wife gives me jobs, I do them. When she gives me too many jobs, I cannot do them all, right? That's just the way that it is. I am like a database. I prefer just a couple of jobs here and there. So if you can query a database at the level that it's actually intended to, you don't have to scale it up to $1 million. No. You could just use something like cache to make it so you call it less often. Especially, think about that drop down in your UI that's a list of all the countries or a list of all the states or whatever it is that is special to your company that you call from a database so it can always be the same for every user. And why wouldn't we cache that? Why wouldn't we put that into memory? Memory is cheap. Memory is easy. If memory is lost because we recycle the container, then we'll just fill it up again. No big deal. And it's so nice. You don't have to, 1,000 people log onto your application and 1,000 people need to know the list of countries again. Absolutely not. There's one other thing. There is stampeding. So in the cache world, stampeding means all 1,000 of us ask for it at exactly the same time. And now all of a sudden, even the best databases, like, that's a little too much, right? And so that stampeding is also fixed by using some sort of caching solution like Fusion Cache. And then the second is level 2 cache. So level 2 cache introduces like a Redis server, which is just a name value server, right? Key value, it's nothing. It's just nice and fast, and it doesn't have to do joins and all these special lookups. It's a single index, so it can be nice and quick. And so Redis makes it so that I can pull it out of my database. The expense of the query has already been done. Now I can put it into a cheap storage like Redis, which will be nice and quick because it just has that hash key, whatever it is that I've calculated. All right, that's one easy way, very easy way to make it so your API is so much nicer. You do have to think about it, like what can be cached and what can't. To be honest, if you gave everything a single second of cache, just 1 second, nothing else, you would transform the behavior of your API. There's no doubt about it. Your capacity would go through the roof with a single second of cache. And you think to yourself, I can't afford a second of cache. Are you kidding me? 1 whole second? But I'm just telling you right now that a second of cache is transformative. Absolutely amazing. If a second scares you, I'll tell you, your users, unless you're building like NASDAQ or something, unless you're building like the stock market, then your users won't even know it happened. There's just something about it. All right, so you got to think about it. You're the architect. I'm not you, but just telling you, cache is a great idea. The second is a retry policy, but we live in the real world where sometimes the database is not down. It just didn't respond for some reason. Maybe it's the network, maybe it's the router, maybe it's who knows what, right? I mean, you don't know what happened, but that extra millisecond that it cost was beyond the timeout threshold, and now it didn't respond in time, and you're getting back an exception. Why not just try again? Just one more time. Not a big deal. How many times should you retry? You get to decide that. I set it at 5. There you go. You could be like me if you want to. I mean, we retry. I use exponential bleed off so that it goes nice and slow. But whatever it is that you want to do makes plenty of sense. But not to have a retry policy, especially now that it's built in. Like the SQL driver, you just tell it how many times to retry. You can use poly library or whatever library you want. You can just add the retry policy. This is not an exotic solution. This is just what should be there. All right, so that's just retry policy. You should have that. Another thing we could do to make our API generally better, and that we would naturally do, is to add some sort of queue. Queue is unbelievable. Queue is like now we're into steroids country. Like, it is incredible what we're about to do to our API. We're making it so that we can receive, let's say your database can process 100 things at once. Your API, which is just an API, so it doesn't have to do all the work, right? Have this transactional log or anything like that on the back end. The API just takes a request and hands it off to the database, right? And maybe it does a little business magic in the middle. But that takes no time at all, because you are an excellent developer as well as an architect, so the work that you've introduced is not that big of a deal. That means your database, which is stuck at a limit of 100 operations per whatever, your API is about 1,000, right? It can take about 1,000 at a time. We know that this is actually many commas can be in this number. It's probably hundreds of thousands that it could take. That being said, let's just keep it easy, 1,000 versus 100, which means you could actually take in 1,000 and immediately overwhelm your database. But you have a retry policy. The retry policy takes 1,000 operations and asks your database to do them again. And your retry policy again, because the database always can never do 1,000 operations because it can't even do 101. However, with a queue, you can solve everything. A queue, which by the way is persistent and not in memory, so it's in a file system or whatever it is that makes sense to you. But a queue allows you to take the request that you've gotten from the API, attempt it to the database, and if that database doesn't respond, you can queue it and try again in a minute. Not a minute, but try again when you want. Or you can make it so that you have 100 operations constantly beating at your database's door, and when you get the 101th, when you get one more that is above 100, and you will put it in the queue so that when you've processed those and you have room for another, you take it out of the queue and do it. Why does this matter? Because think of your client. Think of the user. Think of the user's experience, right? They are like, hey, I would like to log in, right? Register me as the green flag. I'm here. Change me from busy to available. Let's just say it's as simple as that. That goes into my API. The API cannot talk to the database because it's so busy, and now they get an exception back. The service is not responding. Please try again. God, this is why people hate us. So instead, we want to say, we received it. Good job. Here's the green flag. The database hasn't even been updated yet. That's because I know that the database will eventually be updated. Now, I can't do this with credit card transactions, but I can do this with most things. That's the way Office saves. It's the way everything saves. Everything is lying to you. Everything is not really doing what it's saying it's doing. It's asynchronous on the back end. It just flips a flag. A little bit like soft deletes, where we're like, sure, I'll delete it, but it's not deleted. When I ask for the API to do an operation and it can queue that operation, it's not really doing it, we know that, but it has put it somewhere where it will guarantee it will eventually do it. right? Now, you know the system, you know what needs to happen, you know what parts of your application could never participate in a queue, but you also know that the other 99% can. And so you might as well make it so that the user has an incredibly positive experience. Now, what happens when your database changes? Well, now we can have something like an event hub. So an event hub is different than a service bus. A service bus takes messages and it hands them around, but an event hub responds to messages. It is the thing that is basically saying, I don't know where. It's a little bit like a postman that delivers to your house versus a postman that stays in the post office, right? And it's like the messages are now available, and they send you a text, come get the box, because it's here. That's a little bit more like what an event hub is, and it's meant to ingest as much as possible, and so as many changes as happen, you can never overwhelm an event hub is the idea. Then, those events get handled one way or another. In your database, like in SQL, for example, we have change event streaming, which means every change to a table could be pointed to an event hub to be able to respond to it. That means you don't have to pull your database over and over and over again. That's really important because every time you query a database, it gets slower. So if the way that you handle data change is to request, hey, have you made a change? Oh, hey, have you made a change? Hey, every single one of those decreases the quality of your database. So instead, we have the database itself say, there was a change. I'm going to send it up to the event hub. The event hub then uses something to do its work. It doesn't do any work by itself. So you would introduce a serverless function here, maybe some sort of application on the side that receives some sort of a invocation through HTTP or whatever it is you decide. And it makes it so that the function then does the operation, sends its own message to the service bus so that whatever system needs to respond, it can, right? That's really, really nice. So think about it from, well, let's use stocks even though we're not building a stock application. Every time the stock price changes, the database sends a message to the event hub. The event hub looks to see whether or not the price is above or below the threshold that you have. That threshold then is finally met. It sends it off to the function. The function says, oh, that's a sell order, that's a buy order, or whatever it is. It does whatever its option is, and now we got to record this, so it sends it to the service bus to do the job. Or maybe the service bus does all of the work, but that's the idea, right? You want it to be able to respond to whatever the thresholds are that you have. If you don't have the thresholds in the event hub, they can be in the function as well, right? It's kind of up to you how you want to end up handling. Okay, that's the role of it. So we've got a lot. There's a lot of little pieces here. If you just step back and look at the entire solution, hopefully every piece here makes sense, right? You're not looking at it, you're like, wow, there's a lot of freaking boxes and lines. Hopefully, instead, it feels like the sort of solution where you're like, I think I could argue for every single piece. In fact, some of these, I think I could argue very vehemently, no doubt, but we're not done. Okay. If I'm up in the Event Hub, one of the things the Event Hub can do is not just talk to your back-end systems, but it can also talk to your front-end systems. This makes it so that we've all used GitHub, I'm sure, and you have your PR, right? And so you submit your PR, and you're looking at the typos that you put in the PR documentation because we all write in our PRs, and then things start happening on the screen, behind the scenes, and they update the screen without you having to hit F5. That's not always how we build our applications. Instead, we have users submit something, and the status is, let's say, yellow, and they wonder if it's going to be green, so they hit F5 again and again and again and again and again and again and again. Right? That's just the natural way that we do it. We've all done it, right? And so the way we get around it is we have a little box that says, please do not leave this window or hit refresh or we will charge you twice. That terror tends to slow it down a little bit, but it doesn't fix the real problem. The real problem is the client has no idea that the backend database is finished with whatever it's supposed to be doing. So now I have it so the database makes a change. It goes to the Event Hub. The Event Hub identifies the change, that this should be told to the user that is now a green flag. And the green flag is now sent to the client, and they have this nice message, and nobody ever has to hit refresh. Not only is this handy, but it makes it so that every time they hit refresh, it doesn't go against your API, it goes against your database and slows everything down. Right? This is nice because this is super unsophisticated, because all I need to do is look to see if the change matters and see who the user is and forward that to them. That's nice. Okay. Through WebSockets, or you get to pick the technology. This is just the concept. All right, so that's the Event Hub. Let's go down. The client itself is going to be served in a handful of ways. I know that most of us are building web applications. I prefer the high fidelity of a desktop application, but it's not realistic in most situations, I understand. So if we are delivering information, not all information is going to change. Sometimes just think about images and things like that, they stay exactly the same. So I'll have a static server that is able to deliver this information because it makes no sense for me to invoke my application or invoke my server application every time I'm trying to read an image. That's always going to be the same, and we haven't changed it in 3 years, right? And so that's really valuable. One other thing about static is in ASP.NET Core, you can enable it with .use static. I'm sure you guys have already done that. But you have to think that because of that by itself, it means that the middleware must still be invoked, right? So, I mean, how can I make it even lower tech is the real question. Could I just drop this in a folder and point to it? And the answer is yes, you absolutely can. So just think about that. If you want to make static even faster, you wouldn't even wrap it in ASP.NET or any other middleware at all. However, maybe you work for a large company that's international and you want to introduce one other little thing. The easiest way to make the experience of the user, who is without a doubt the most important and the most annoying part of every software we write, is the user, right? And to make their experience as positive as possible, we would put it in a CDN to make it so that if they do live in the United States and somebody else lives, say, in Denmark, they don't have to wait for light to travel or for electrons to pass under the ocean. That is for sure, right? Because remember, there is no special tier of any product that can increase the speed of light. Putting in a CDN makes it a little bit faster. Okay, and it's an amazingly straightforward thing to do. Let's talk about what we can do to your database to make it so that it can be faster as well. Each one of these is just yet another component that you'll adopt on purpose. The first is a row store. You already do this. This is for free. This is what you get in every database. It looks like this, where it's stored a little bit like Excel, and it's just the normal way of storing data. However, some tables actually don't belong in a row store. They belong in a column store. Column store is not an extra thing that you install. It's this package that you go and get. It's a checkbox on a table, and suddenly it is a column store. Column store takes all of the data that is usually stored horizontally and turns it to be vertically. This is extremely fast. I can't even start to tell you how much faster a column store is. Well, I can actually tell you, yes, we've done the benchmarks, and it's around 100 times faster when you're running aggregates against your data. 100 times faster, and it's a checkbox on your table. It is amazing. The other thing that it can do is it can compress a table dramatically, making it so that this monstrous thing that's taking up all this disk space is suddenly nice and tight only because you made it a column store. Now I know what you're thinking. How do you write a SQL statement against a column store versus a row store? And the answer is there is no difference. You will not know that it is a column store from your experience. We just do it on the back end, right? And so you still interact with it like normal data, joins and all the things. And everything just as magically faster. Not every table needs to be a column store. Don't let this be how you learn about what column stores are and then go implement them. Let Google teach you a little bit more. Ask ChatGPT to explain it. However, column store is the magic sauce that nobody is using for some reason. And it is an incredible way to speed up your database. And it looks like this, if you didn't know what columns were. Okay, now, beyond that, there is also a table with no index. Let me explain just for a second that every table that you create with a primary key is automatically indexed, like it or not. You don't know that it's happening, but it's happening. And here's why, and it is called a clustered index. The reason a clustered index is awesome is it keeps things physically in order. And that is not the worst. It is not the worst. However, if your key is not automatically generated, and it is not in series, and it is not numeric, then it makes it so that it is possible for you to introduce a key that belongs in the middle. And when you do that in a clustered index where it will always keep them physically in order, it will rearrange the rest of the table to make room for that column, for the row that you just inserted. It's the way that it works. It's the reason that everybody's like, you're using a GUID for your key? Yeah, that is part of the reason that it is scary to use a GUID for your key. Because a GUID is obviously not in series, especially if it's generated by different machines. And then when you merge them all together, the table constantly has to reshuffle in order to keep things physically put together. However, like a hash table in coding, no index table is a hash table in a database. It is the absolute fastest way you could ever write to any database table in the universe. There is no technique that's any faster than this. You insert into a no-index table, and it immediately writes. There is no delay. It does not have to update it to index. It does not have to change the order of the table. It just takes the record however you gave it to it and drops it in. That's as fast as you can get it. It is also the most dangerous table you can possibly imagine, because take all of the constraints and controls, take all the reasons people love relational data, throw that into the garbage, and just call that your database, and it's not the same, right? So there will be times when you need a table that is insanely fast. And you'll be like, that guy at NDC said something about just taking off the primary key. And I was right. It is going to be insanely fast. Just be careful, right? Just Google it first, is all I'm saying. All right. Next, almost every database, like SQL does, includes in-memory tables, right? So you can take a table and you can remove it, or you can extract it from the file itself, put it into RAM, which is insanely fast, just like level 1 cache was, and you could treat your database table as if it's level 1 cache. Is it faster than Redis? It is. It is insane. It is an incredible way because everything is just sitting there in memory, and it is beautiful, and you can read and write, have the same transactional experience and all the things, and you have no knowledge that it's in memory other than this table is crazy fast. And you can even write to it fast, too. Take the index off, it'll be even faster. However, what's the downside is if you recycle your SQL Server, then everything in memory is lost. That's true. There are two ways to create an in-memory table. The first way is to make it so that everything is in memory, and that if you recycle your database, it's lost. The second way is to make it so that everything is in memory, but when you write to it, it also writes to the file system. Is that slower? Yes, of course, because you have to write to the file system. Is reading from that table still fast? Insanely fast. There's nothing faster. It's just as fast as lightning can be. Okay, so you can have an in-memory table. I recommend looking into it. Google it first. Don't just do it. The next is moving things into relational graphs. So in SQL, for example, we support graph databases, where you can do like matches across relationships. That could be extremely useful, especially in scenarios where you're working with, let's say shipping or something along that, like where you have a warehouse, and then you have a shipping lane, and then you have, well, let's say it's a factory that makes it, shipping lane, warehouse, another shipping lane, and then you have the final distribution center. So those 3 stops and then trucks across or whatever it is. Each one has its own cost and time, and you want to say, what's the fastest way for me to get from the factory all the way to this distribution center? I don't care which warehouse I go to. Just show me the fastest in time. How about the cheapest? And maybe you have multiple warehouses, multiple trucking lanes, and you can figure all of these things out because of a graph database, right? So it's very valuable. And the nice thing of having it inside your relational database is that you don't have to worry about moving any of the data out, right? It's already there. You already have it secured. You don't have to worry about it. You can just use the graph capabilities. The last thing, and I'll just be honest, NoSQL is probably going to be coming up more and more for you, just because it's easier to just accept a payload from somebody and hold it. You might extract different pieces from it and be able to use those, but you don't want to throw the rest away because you're like, information is still information. Fine. So I'll talk specifically about SQL Server. In this case, SQL Server puts all NoSQL into a binary format, making it so it's as fast as regular data, so you can manipulate individual properties without having to load the whole thing. Also has a 2 GB limit, if you can imagine, something crazy like that. And just imagine doing a select star from a table with 2 GB. Okay, so also NoSQL, let me just move on. Okay, so here's where we are now. We're not done, but I just want you to see how things can build up, and it's not a bunch of insanity. Right? We're just thinking about how we can make it a better experience for the user, better experience for you when you need to upgrade, and things like that as well. All right, let's talk just for a moment about the API. I told you I'm on the Data API Builder team, so let me just give you 30 seconds on that. Data API Builder is open source and free, supports Postgres, SQL Server, Cosmos, and MySQL. Honestly, it can replace 90% of all of the data APIs out there. If you have a separate project where you said, start new, or file new project, and you say Web API, and you're creating your minimal API so that you can use Entity Framework to talk to your backend database, you could probably erase the entire project with Data API Builder. It's the reason we built it. It's because it's just the same repetitive code over and over again. We call it copy and paste inheritance when you get bugs from one project to another, because it's the sort of thing you do once and you copy it to the next project and just change your POCO objects or change your DTO objects or whatever they are. So Data API Builder is AKMS/DAB. Again, it's open source. You could just add this, right? It's really nice. It's not language dependent. It works on every platform. It's delivered as a container. It's really nice. You also get GraphQL endpoints if you want. That's not what we're talking about now. So you add to your client extra capability. Because AI is all the rage, we add OpenAI to it so we can chat with it, and it can start interacting with us in different ways, and it actually can be pretty nice. This is where you would put it. It's not part of your backend. You're not going to host, likely, OpenAPI. You're going to let somebody else host it, like maybe Azure. Microsoft could do it in Azure OpenAPI, and or wherever it is, right? So you have your model sitting right here. But in order for that model then to talk to the rest of your data, you're going to introduce a remote MCP server, right? So the remote MCP server allows for your model to talk to the MCP server. Your MCP server then is talking to your API. Of course, it's not talking to your database. That's ridiculous. You would not let anything talk directly to your database. And over your dead body, would you allow a model to write SQL and execute it against your database? Like nobody would do that. So we don't even have to talk about that, because you would not believe how many customers are like, oh, I just wanted to write the SQL for me. And you just can't believe that they're still employed. So now back to the client. The client itself can be easily improved, made so that you can give it a beautiful offline experience, making it so that if the user is working from home and there's a lightning storm and they lose their internet service for 5 minutes, everything works the same. It's a little bit like the Outlook experience, right? You don't know if you're connected or not. You just kind of hope you are, because it's awfully nice. But that's because I can go in and out of a tunnel, and Outlook does not make me mad, right? It makes me mad for other reasons, but it doesn't make me mad for that, because it does fine offline, because I've introduced the ability to cache my requests and then to cache my requests and to queue my responses. Am I saying that backwards? To queue my requests and cache my responses. That's what I meant to say, right? Where everything kind of sits there in an inbox sort of experience, simply because you've added a cache and queue, which is such a simple little package to add to your client so that you can give this capability to your user and they think of you in good ways, right? Because they're like, oh, every time you're the architect, these apps just freaking work. I'm like, I'll tell you why. We added the thing that makes it nice. Okay. Let's go over to the other side. Now these systems, including yours, all are going to be moved into some sort of lake where you can take your data and you can use it together. This is super important, because if you just leave it siloed in one, then there's no value. And so instead you have some sort of ETL or EL process that moves it into a data lake. And the role of the data lake is to run all of your reports. Everything is in one place. And it's very difficult to get your data into a place where you can query it and love it. But nonetheless, if you're going to do it, it's going to be in a lake. What is a lake other than an enormous database or just a big file system full of your data? That's all that a lake is, right? I mean, you can always pay somebody to have a lake, but that's all that really is. Okay, now, the reason that we have a lake, though, is because we have an ML operation. And the ML operation is looking for all of the things, right? So maybe for you, it's going to recommend to your customer a series of products that that's related to what they've already looked at, or whatever it is, right? And so you have a mechanism to do this, and the easiest place to do it is against your lake, where you have all of your inventory, you have all of your operations, everything in one place. Beautiful. However, it can't stop there. You must make it so that your ML data gets pushed back into the systems. Otherwise, it's never useful at all. If it only shows up in your reports but doesn't show up in your applications, you're not really taking advantage of the magic. Like, the reason you can do all these things is not just to make it so your dashboards are better, but to make it so that your customers have a different experience because of the magic you've added in the ML layer. Okay, there's a little bit more. We really don't have time to talk about security. But let me just say this really quickly. All right, so Azure Active Directory was renamed to Microsoft Intra ID. Why? Because we all know what it is. All right, so Intra ID might be what you do, whatever it is that you use to create a principal. It is how you will also generate a JSON web token, right? And so this takes all of the things about you, groups it together in a nice little JSON block, and then signs it cryptographically and then sends it on. Then the receiver can then unsign it or verify the signature that you have against the authority or Intra ID or whatever it is that you use. Then read on the inside once it's validated to say, oh, you can do this, 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 and this. Okay, no problem. Oh, and that's your first name. I can call you by that. It's really nice. Like, JOTs are handy. What you might want to do, and I think you at least want to consider it, is to be able to take a JOT and recreate it in your application. And here's the reason I want to say it. You might feel like the 7 tabs inside your application belong inside your Active Directory tenant or inside your Intra tenant. as do all app developers. They all feel as if the fine-grained details of their application should be controlled inside their tenant. And if you do that, it's not wrong, but it's a real pain in the neck. Instead, you want to have the high-level categories in your tenant pushed down to your application, and then your application to do the fine-grained access control and rewrite the JOT for you. That JOT then, which was already validated, everything's cool, you're handing it to all the systems that you have in this solution, and it can see both the original JOT that is in Enter ID so that you can validate it if you need to for important resources, but you can also see the fine-grained access control that you have just for your application. If none of that makes sense, then it's totally fine. But I'm just telling you, a system that has its own JOT server is a system where you know there's somebody thoughtful there. It's one of the most dangerous things you can also add to an application if you do it wrong, so Google it before you do it. All right, so let's look again. It's not outrageous. When we started, hopefully this felt overwhelming and is going to be exhausting to talk about, but it's not. Each one of these hopefully feels like you could argue it out of your solution. That is my number one goal, is for you to be like, okay, I'll tell you one thing, why we don't want caching in our API. Great, that's what I want to hear. Once you understand it enough to be able to understand why you don't want it, then you finally have enough why you would actually want it, right? Because you have to realize the caveats, because you as the architect are going to be the one that ends up getting your neck wrung for it. Okay, remember, simple is the best architecture, and I don't actually have a tattoo about that, but if there's one little takeaway, it would just be this. There are other things too. This slide was at the beginning, and I'm like, there's so much we have to cover. I had to take it out, but there's so much more that you get to think about. All right, this is the final takeaway, is to defer decisions. It feels like as an architect, I have a responsibility at the beginning of a project to make all the decisions now. And if I don't, then that one jerk on my team is going to make the decision, so I need to make it ahead of them. Right? That's usually the way that it goes. But the truth is, the longer we can put things off, the cheaper they will be in the end. Not cheaper necessarily to implement, but cheaper to change your mind when you realize you made a mistake. It's just one of those things that the less you put in, the better it is all the way around. All of us are architects, and if you think about it, even a junior developer has to architect a solution around the class they're responsible for. So we all have this sort of nature to it, and less is always going to be more. All right, so, oh, beautiful. That's it. All right, thank you, everybody, for listening. There you go. I'll be up here for questions if you have any. Actually, if you want to shout out a question, here, I'll throw it back up there for a second. If you want to shout out a question, I will. Let me back up to the money shot. There you go. Anybody? Yeah. Sorry, I couldn't see you. Yeah. Go ahead. You. Good point. He's saying that framers like Aspire sometimes hide the complexity behind the scenes. What's the downside? Oh, because it makes it so simple on the developer experience, it can make the production experience very complex. That's a great point. Yes, sir. You should Bing it. Yeah, you should Bing it. Bing's the only one that pays you back, right? Pennies. Thank you. That's great. Anybody else? Yeah, Copilot. It's not ChatGPT. I've said all the wrong words. And I did say SQL Server. I mean, I felt like a shill up here saying it so many times. Anybody else? All right. Thanks, everybody. Bye-bye.